welcome to another Simply Diagnostics video. Thanks for watching.
Today we're looking at a 2012 Skoda Yeti 1.8 TSI with a CDAA engine logging P0088 fuel pressure too high fault. The vehicle originally came to me with a P0016 cam crank correlation code. The timing chains have all been done on it, and now since the chains have been done, like I say, it's logging a P0088 rail pressure too high code. So we're going to, first of all, we're going to verify the timing with the WPS 500. We're going to have a quick look, we're going to whiz the pump off, have a quick look at the bucket on the pump, and we'll go from there. I hope you enjoy the video. If you do like it, don't forget to hit the subscribe button and the bell for notifications. So this is the code it first came in with: 000022 P0016 cam crank incorrect correlation. There was also an idle air fault and multiple misfire codes. And then sliding over, this is what we've got now: P0088 fuel pressure rail pressure too high, and it is definitely too high. So just a quick overview of the engine bay. There's the engine code down there. I don't know if you can see that. Let's see if we can zoom in on it for you. CDA, it's CDAA. Obviously, coil packs, high pressure fuel pump, high pressure fuel regulator. This part here, the injectors are buried down there, and the rail pressure sensor is there where my finger's pointing at, down there. So what we're going to do now, we're just going to quickly whip that high pressure pump off and just check the bucket to see if the bucket's okay. Right, so let's get stuck in taking this pump off. First thing we're going to do, it's not been started for about half an hour, so we're just going to relieve fuel pressure by cracking the pipe off. This is high pressure pipe to the injectors. Slowly, we don't want to be damaging the threads or anything like that. Always a little bit awkward to get into these, and camera's slightly in the way. Right, that's the high pressure union off. Take the key out, make sure that nobody turns the key on while we... So unplug the fuel pressure regulator. The easiest way with these bag connectors, just push it in slightly, pull the tab up and pull back. There's no need to wrestle with these whatsoever. Couple of Torx 30s, one at the bottom and one at the top. We'll do the one at the bottom first. Always do the difficult one first if you can. Always do the difficult one first. They can be quite tight, these, but once they go, they go. That's it, she's gone. Just loosen this one as well. That's it, she's gone as well. I should really take the airbox out of the way to give myself a bit more room. Don't know whether you can see there, is my big fat head in the way. Right, so we'll not tempt Providence by trying to drop that screw. We'll just feed a magnet in and pull it out. There's one. And the second one. I just heard the plunger go back on the pump. Two. Get that wire out of the way. And what we're doing here, we're just doing a physical inspection of the pump. So there's the pump in all its glory. Can you see that? There's the pump in all its glory. No sign of wear on the end. You just pull the bucket, tap it out. Can you see that here? Yep, you can see the bucket, tap it in there. So we just slide the bucket, tap it out. It's a bit tight, that. So that's the bucket, tap it. With the roller on the end. No sign of wear on the roller, tap it. No sign of wear on the inside. Just get a torch now and have a quick look inside. See if we can get you zoomed in a little bit more. And that's the inside, and you can see there, that's where the camshaft's riding, the roller tappet's riding on the camshaft. There doesn't appear to be any wear on that either. So as far as the physical inspection goes, the pump seems to have passed, the roller tappet seems to have passed, the bucket's okay. So we really are looking now, we're looking at either a control issue or a failure of the regulator. Right, so we've started this up running, checked for leaks, there's no leaks there. But we're looking at measuring block 106 here, and what we can see is the specified pressure at idle is 40 bar, and our actual pressure is 188 bar. The duty cycle of the pump is 89%. That's really trying very hard to reduce the rail pressure. So what we'll do now, we'll get a scope on it and just have a look at a waveform from the regulator. Right, so what we're going to do now, we're just going to scope the fuel pressure regulator. I'll just show you through my hookups. So we've got the peak scope 4425 channel A. We've got going into the control wire, the blue cable we've got going into the control wire on the fuel pressure reg, and channel C, which is the green trace, we've got the snap-on low amps clamp ETA 503C measuring current on the control wire. And we've got the key on now at the minute. There's no codes logged. If we look at the scope settings, we've got it on a 10 millisecond time frame. channel A on a 50 volt scale because we've got an inductive kick off this solenoid, which I'm really not sure we should have. And we've got channel C on a 1 volt setting. It's 100 millivolts per amp. So at the moment we're pulling about 2.72 amps, 2.73 amps. And the duty cycle at the minute, if we go back, so switching over to live data on VCDS, we go advanced measuring values. High pressure fuel on this vehicle is MVB 106, so we type 106 into the search box, that brings it up straight away. We'll select fuel rail specified, fuel rail actual, fuel pump duty cycle, minimise that, get it out of the way. Just with key on, we've got 40 bar specified, we're actually running at 190 bar and 2.7% duty cycle. So we'll start the vehicle and see what happens. I'll leave you focused on that screen. Foot on the clutch to start the vehicle. See the duty cycles increase, the rail pressure's dropped a little bit. We scoop over onto the scope. And we look at this ruler now, we can see that the reg is actually pulling. The fuel pressure reg now is actually pulling 913 millivolts, that's nearly 10 amps, which is way too high. And we look at the duty cycles clearly increased, and there we go. That will be that change there. It's just happened. You see, it's almost like a multi-strike effect. It's really trying its hardest. It's gone into default mode. Look at the current spikes. Yeah, this needs a reg. And then if we look at the duty cycle for the pump now, you can see 89.4%. And that's just at idle. And we'll flick back over onto VCDS. If I go back into fault codes now, you should see it'll log the fault code. 00136, fuel rail system pressure too high. P0088. Well, if we just quickly jump over into OBD, so I'll quickly jump into OBD now and see if we can see anything different, if it gives it a different description. Permanent DTCs mode 10. No fault code found. Mode 7 pending DTCs, 1 fault found. P2293 fuel pressure regulator valve mechanical malfunction. So short-term trim, we've got nothing. Mass airflow 2.9 grams per second. Long-term nothing, that's because the codes have been cleared. I don't think it'll give us a fuel pressure. Oh, there you go. 15,200 kilopascals relative. But the interesting thing is that waveform. Have you ever seen anything like that in your life? So what we're going to do now, we're just going to shove a WPS down the cylinder just to physically check that the timing's okay, and we'll go from there. Now setting the scope up, what we can do is close all the rulers for a start, turn channel C off. Channel A, we're just going to go on a 20 volt scale. Channel B, we're going to select our probe is WPS range 1, and we'll set it for the middle of the range. We'll put it on 100 milliseconds, a million samples should be alright, and we'll change our trigger from channel A to channel B. Right, so we've got our scope set up now. 1 second for the screen time. We've got it on the mid-range 30.8 bar setting, and we've got the trigger on channel B, so we'll see what happens. So drag a couple of rulers across from the right hand side. Already got 4 partitions up on it. We'll zoom in on the expansion pocket here. That's TDC. Zoom in there a bit more. Drag a ruler down from the right hand side. It's actually changing direction. It's about 6 degrees, starting to close about 6 degrees after bottom dead centre. I'm not so sure the timing's right on this, if I'm honest. So looking at this waveform, we're looking at the expansion pocket here. The normal rule of thumb is the exhaust valve should be opening between 30 and 50 degrees before bottom dead centre 180, which is this mark here. So we're looking basically for a change in direction of this ramp 30 to 50 degrees before bottom dead centre. So if I put one ruler on there. Now this ruler I've got on here is 130 degrees from TDC, so that window there is basically 50 degrees before bottom dead centre. But if we zoom in closer, you can see the actual change in direction where the negative pressure starts to increase and go back in a positive direction is actually after bottom dead centre. So that indicates possibly that the exhaust timing is out, and that would also tie in with the fact that the fuel pressure pump, although it's not timed, is driven by the exhaust camshaft. So maybe we might need to have another look at this exhaust camshaft timing. It's all interesting stuff. Right, so in summation with this video, there's obviously going to have to be a bit more of a follow-up, a bit more work put into this, but in summary, I'm not happy with the inductive spike on the rail pressure control solenoid. I'm also not 100% happy with the exhaust cam timing. We're going to have to revisit that again, I think. We'll get the lads to do a physical check on that again for the third time. But yeah, so I think for the rail pressure regulator, looking at that inductive spike, I've not seen that on a rail pressure regulator before. I could do with grabbing a known good. So if any of you out there have got a 1.8 TSI CDAA engine, if you could scope the rail pressure control solenoid and throw that over onto the YouTube group. There's a thread on the YouTube group, Simply Diagnostics YouTube. If you could throw that onto there and join in the discussion, that'd be awesome. So yeah, so it's a bit open-ended this, but I was always sure this was going to be a multi-part video. So we'll see how we go.
And thanks for watching the video. If you liked it, don't forget to leave us a thumbs up, hit that subscribe button. If you didn't like it, give us a thumbs down, put in the comment section below and let's get a conversation started. We've also got ways you can support the channel now if you look in the links below. We've got Patreon, buymeacoffee.com and a direct PayPal link. Thanks for watching and thanks for supporting the channel. You're awesome.